A hearty welcome, students. So in this video, we are going to understand the chapter of inverse trigonometric functions. So this is a very important chapter in your 11th and 12th class, and it's mostly a concept oriented chapter. That is, if you understand the concepts, then you will really enjoy this topic. So this topic is divided into certain subtopics. So the first subtopic of this inverse trigonometric functions is understanding of domains and ranges of inverse trigonometric functions. So domain and ranges of ITF. So ITF denotes inverse trigonometric functions. And next, after understanding the domain and ranges, we are going to try to understand the graphs of inverse trigonometric functions. Graphs of ITF. So these graphs are very useful in visually trying to solve the questions. Next, you have the topic of what you call properties of ITF. Properties of inverse trigonometric functions. So these are the properties that we use to manipulate the trigonometric functions, and in analytical problem solving, these properties will be very useful. And fourth, so after properties of inverse trigonometric functions, so we have again what do you have after this? You have formulae section. So if you take any standard textbook in inverse trigonometric functions, there are lots and lots of formulas. So we are going to understand how we can write those formulas without actually memorizing them. So if you understand the concept behind the formula, you can write the formulas directly. So formulas are divided into two things, which are compound angle based formulas. Compound angle based formulae and multiple angle based formulae. Multiple angle based formulae. Okay. So next, after understanding the formulae, the last and final topic that we are going to study is some special graphs. So related to multiple angle based formulae. So these special graphs will be very useful in trying to understand the higher level questions. So once we understand all these 5 topics, which we are going to do as we go forward, so then there are some special types of questions. So we are going to discuss them. And once we discuss all these things and you understand all the nuances of these concepts, so most probably you will be able to do almost all the different types of questions in this chapter. And you'll also be able to appreciate the concept behind each and every question. And you'll really enjoy this topic. So let us first go for the understanding of domains and ranges of inverse trigonometric functions. So let's go forward. So domain and range of inverse trigonometric functions. So the first thing that we have to understand is that inverse exists only for bijective functions. So even before going there, so what is the meaning of inverse? So for example, sine of pi by 6 is equal to 1 by 2. So sine is a function. You can think of y is equal to sine x as a function. So what goes inside sine x? Okay, angles go inside sine x. The angles may be in degrees, the angles may be in radians, or any other measure. So when an angle goes inside sine, the value of sine x, which is defined as some sort of ratio, as you know in trigonometry, so that is the value that comes out. Okay, now the question is something like this. So what should go inside sine? So what should go, what is the value of the angle that goes inside sine to give half as the answer? So if I ask you this question, your answer will be obviously pi by 6. So what is the angle that should go inside the sine function to give you the answer of root 3 by 2? If I ask you this question. So this is a question on trigonometric equations, right? So sin x is equal to root 3 by 2. There are lots of angles which which can go inside sine to give the answer as root 3 by 2. For example, the answer to this is x is equal to n pi plus minus 1 whole power n times pi by 3, where n belongs to integers. So this particular concept is called inverse function. So I say that sine inverse x, if I ask you sine inverse of root 3 by 2, what I am asking is what is the angle that needs to go inside sine to give you the answer of root 3 by 2. So theoretically you have many angles which can give root 3 by 2 value when they are sent inside sine function. So the answers may be pi by 3, 2 pi by 3, pi, 2 pi plus pi by 3, 3 pi minus pi by 3. There are lots of angles. So in this case, we say that the function sine is not a 1-1 function. The function sin x, as you know, is not a 1-1 function. That is, different values of x don't give different values of y. There can be multiple values of x which give same values of y. And the understanding is that in functions, the inverse function exists only for bijective functions. And a non-1-1 function can be made into a 1-1 function by appropriately restricting the domain. So what we do is we restrict the domain from minus pi by 2 to pi by 2. We are taking only the sine function between minus pi by 2 to pi by 2. And if you take only this arm, you can see that if you define sin x from minus pi by 2 to pi by 2 to minus 1 to 1, so this function is a bijective function, and we define the inverse trigonometric sine, that is sine inverse x. The sine inverse x is defined from minus 1 to 1 to minus pi by 2 to pi by 2. So sine inverse x is defined from minus 1 to 1 to minus pi by 2 to pi by 2. Okay, that is sine inverse x takes in values from minus 1 to 1 and it gives out the angles from minus pi by 2 to pi by 2. So this is a general convention. So there is no hard and fast rule that you have to take only minus pi by 2 to pi by 2 to make it into bijective. You can also restrict the domain from pi by 2 to 3 pi by 2. So with this domain also, the function will become bijective. But this is a standard convention, and the inverse sine defined with this domain and this range is called principal value. This is called principal value inverse trigonometric function. Okay, if unless otherwise mentioned, we'll take the principal value branch of sine and define its inverse. So in this way, the general, sir, why did we take only from minus pi by 2 pi by 2? The general convention is that we try to get the minimum numerical value of the angle. For example, if you have sine inverse of minus 1 by 2, you know that you have lots of different angles for which sine inverse is minus 1 by 2. But what is the angle for which the numerical value is the least? So minus pi by 6, this is one value. The next value where sine inverse is sine is minus 1 by 2 is minus 5 pi by 6. So if you want to take in the positive angles, it will be 7 pi by 6, pi plus pi by 6. So there are different angles for which sine inverse is minus 1 by 2. So for defining the principal branches or principal value branches, so the general convention we take is we take the particular angle whose numerical value is the least. So following this convention, sine inverse is defined from minus 1 to 1 to minus pi by 2 to pi by 2. That means, so into the sine inverse function, so the numbers from minus 1 to 1 can go in, and the answers that come out are in between minus pi by 2 to plus pi by 2. Do you understand? So clearly, if positive numbers go inside sine inverse x, the angles in the first quadrant are going to come out. If positive numbers are going inside sine inverse, the angles that are going to come out are in the first quadrant. And if negative numbers go inside sine inverse x, the answers that come out will be in fourth quadrant in clockwise direction. That means negative acute angles. So this is the standard convention for sine inverse. So the same type of selection from minus pi by 2 to pi by 2 will not always work for every trigonometric function. So every trigonometric function has its own general restriction for principal branch. So let us first look at what is the restriction of domain and range in which inverse functions are defined. So for sine inverse x, so the domain and range, so domain is minus 1 to 1 and range will be minus pi by 2 to plus pi by 2. That means the numbers that sine inverse can take are minus 1 to 1 and the answers that come out of sine inverse are ranging from minus pi by 2 to pi by 2. So the same restriction will not work for cos inverse. If you look at cos inverse, the graph of cos inverse will be like this. So if you take the restriction from minus pi by 2 to pi by 2, this will not become 1, 1 and the complete range is also not covered. So the general convention is for cos inverse, you take the branch between 0 to pi as the principal branch and you define the inverse in this domain and range. So cos inverse x is going to have the domain minus 1 to 1 and the principal range is 0 to pi. 0 to pi. So similarly, taking into consideration the graphs of different functions, you have the corresponding domains and ranges. For example, if you take tan inverse x, so the tan inverse x, you know the tan x graph, the basic tan x graph ranges from minus pi by 2 to pi by 2. This is how the graph looks like. So if you take the basic arm of tan x, it is a bijective function. So tan inverse x is defined from minus infinity to infinity. The range of tan x will be the domain of tan inverse x. The domain of tan x will be the range of tan inverse x. So in which domain is tan x inverted? Minus pi by 2 to plus pi by 2. Because tan pi by 2 and tan minus pi by 2 are not defined, the domain for tan x is open minus pi by 2 pi by 2. So the range for tan inverse will be open minus pi by 2 to plus pi by 2. Similarly, cot inverse x. So if you take cot inverse x, the basic arm is chosen as 0 to pi arm. Because actually, if you take cos inverse x, you can as well take minus pi by 2 plus pi by 2 also. In this minus pi by 2 plus pi by 2, in this interval also, cot x is bijective, but there is a discontinuity in between, which is not good. So we take the domain as 0 to pi and range as minus infinity to plus infinity for cot x as the principal value branch, and cot inverse x is defined with a domain of minus infinity to infinity and the range is open 0 to pi. Similarly, cosecant inverse x is defined from minus infinity to minus 1 union 1 to infinity to minus pi by 2 to plus pi by 2 except 0. Because cosecant inverse x cannot be 0, because cosecant 0 is not defined. Okay, so cosecant inverse cannot give you 0 as the answer. Okay, so similarly secant inverse x is defined from minus infinity to minus 1 union 1 to infinity to close at 0 to pi except pi by 2. So these are the domains and ranges on which the inverse trigonometric functions are defined. So it is very good if you can remember all these domains and ranges. So to make it easy for you to remember these domains and ranges, we divide the inverse trigonometric functions into two groups. Okay, so group 1 will have the ranges related to minus pi by 2 to plus pi by 2. So these three inverse trigonometric functions are in group 1 and these three inverse functions are in group 2. Okay, so group 1 has, if you see clearly, sine inverse, tan inverse and cosecant inverse. So we will divide the inverse trigonometric functions into group 1 and group 2. So group 1 has sine inverse x, group 1 has tan inverse x, group 1 has cosecant inverse x. So all these three functions ranges are related to minus pi by 2 to pi by 2. But not all are exactly same. There is minor difference between the ranges. For sine inverse x, the range is minus pi by 2 to pi by 2 closed. For tan inverse x, the range is minus pi by 2 to pi by 2 open. And for cosecant inverse x, the range is closed minus pi by 2 to pi by 2, except the number in between them. Between minus pi by 2 pi by 2, what is the middle number? Minus 0. So you can remember it, remember the ranges in this way. And group 2 has cos inverse x, cot inverse x, secant inverse x, and these ranges also are slightly different, but they are all connected to 0 to pi. So cos inverse x range is 0 to pi, cot inverse x range is open 0 to pi, secant inverse x range is closed at 0 to pi, except the number pi by 2. So group 1, group 2 has a basic difference in the behavior. Okay, what is the basic difference? So when positive numbers go inside these inverse trigonometric functions, the angles that come out are always in the first quadrant. For example, sine inverse x, positive numbers, the positive numbers that can go in are 0 to 1. So take any number between 0 to 1 and send inside sine inverse. You'll always get an angle in the first quadrant. The tan inverse x domain is minus infinity to infinity. So take any positive number and send inside tan inverse. You'll always get number in the first quadrant. Okay. Similarly, if you take any valid positive number and send it inside the inverse trigonometric functions, the answer is always in the first quadrant. The difference between group 1 and group 2 comes in when negative numbers are going inside. So when negative numbers go inside the group 1 inverse trigonometric functions, you get angles in the fourth quadrant with a negative sign. And if negative numbers go inside the group 2 inverse trigonometric functions, you get angles in the second quadrant. Okay, so let us first understand from very basic examples how this is going to work. For example, so let us take sine inverse of 1 by 2. Okay, sine inverse of 1 by 2. 1 by 2 is going inside sine inverse. It's a group 1 inverse trigonometric ratio. So the answer will be in the first quadrant. So the question is, for what angle sine is half? The answer is pi by 6. What is tan inverse of root 3? What is tan inverse of root 3? The question that you need to ask is, for what angle tan theta is root 3, which is 60 degrees, right? Pi by 3. For example, tan inverse of maybe 2 minus root 3. So you might ask me, what is the question that you need to ask is, what is the angle for which tan theta is 2 minus root 3? So you know that tan 15 degrees is 2 minus root 3. So the answer is 15 degrees, or in radians it is pi by 12. Okay, so when positive numbers goes in, the answers are quite simple. So what happens if negative numbers goes in? What is sine inverse of minus half? So for what angle sine inverse is minus half? So you have to think, when negative numbers goes inside group 1, you are going to get an angle in the fourth quadrant. So you know that sine inverse of sine of minus pi by 6 is minus half. So minus pi by 6 is going to come. So similarly, tan inverse of maybe minus 1 by root 3. It's simply the negative of tan inverse of 1 by root 3, which is minus pi by 6. Similarly, tan inverse of root 3 minus 2. This is minus of 2 minus root 3. So tan pi by 12 is 2 minus root 3. Tan minus pi by 12 is minus of 2 minus root 3, which is root 3 minus 2. So minus pi by 12. Clear? So when positive numbers goes inside the group 1 inverse trigonometric functions, you got positive angles as the answers. When negative numbers goes inside, you get negative angles as the answers. For group 2, there is a slight difference. For example, cos inverse of 1 by 2 is equal to pi by 3. Cos inverse of minus 1 by 2 will not be minus pi by 3, because actually speaking, cos of minus pi by 3 is not minus 1 by 2. Cos of minus pi by 3 is also plus 1 by 2. So when negative numbers goes inside, so you're going to get an allied position of pi by 3. Allied position of pi by 3 in the second quadrant. So what is the allied position of pi by 3 in the second quadrant? Pi minus pi by 3. So you're going to get pi minus pi by 3, which is 2 pi by 3, which is in the second quadrant. So I hope you are trying to follow this. For example, cot inverse. For example, cot inverse of 2 minus root 3. So you know that what is cot inverse of 2 minus root 3. Okay, so tan of pi by 12 is 2 minus root 3. So cot of 5 pi by 12 is 2 minus root 3, right? So you have 5 pi by 12. So cot 5 pi by 12, which is 75 degrees, is 2 minus root 3. Similarly, cot inverse of root 3 minus 2. This is going to be not minus 5 pi by 12. So it is going to give an allied position of 5 pi by 12 in the second quadrant, which is pi minus 5 pi by 12, which is going to be 7 pi by 12. Okay, so the basic understanding of inverse trigonometric functions is that based on the nature of the range, inverse trigonometric functions are going to be divided into two parts, group 1 and group 2. In group 1, you have sine inverse, tan inverse and cosecant inverse. In group 2, you have cos inverse, cot inverse and secant inverse. So group 1 ranges are related to minus pi by 2 to pi by 2. Group 2 ranges are related to 0 to pi. There is minor difference in the exact ranges, but they are related to those numbers. And if you take group 1 or group 2, if positive numbers go inside, if positive numbers are going inside the inverse trigonometric functions, the answers are always in the first quadrant. The main difference is when negative numbers are going inside. When negative numbers go inside, the group 1 ITFs are going to give you the angles in the fourth quadrant. When negative numbers go inside group 2 ITFs, the answers are going to be in the second quadrant. So, and the angles are also allied, if you see, because sine inverse of 1 by 2 is pi by 6, sine inverse of minus 1 by 2 is minus pi by 6. Those two are allied angles. Cos inverse of 1 by 2 is pi by 3, cos inverse of minus 1 by 2 is 2 pi by 3. These are also allied positions. So you know what allied positions are, right? So for every angle theta, the reflections of this position with x-axis and y-axis, with respect to x-axis and y-axis, these four positions are called allied positions of this ray. Okay, So if, for example, even secant inverse of theta, secant inverse of some number is theta, secant inverse of minus of that number is going to be pi minus theta, the allied position in the second quadrant. Cosecant inverse of something is theta. Cosecant inverse of minus of the same thing is minus theta, the allied position in the fourth quadrant. So if group 1 negative numbers goes in, you get an allied position, allied value in the fourth quadrant. If negative numbers are going inside group 2, you get allied positions in the second quadrant. So this is the basic understanding of the domains and ranges of inverse trigonometric functions. So I hope you have enjoyed this topic. So let's go to the next topic.